Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG, and I am excited to be here in the second video in this series, specifically about exponential and hyperbolas. Now, when I look at exponential graphs and hyperbolas, there's a lot of nitty-gritty things that are asked inside of this kind of question. So you have to know your theory. If you do not know your theory, I encourage you, please go and make a summary, like the one I did on parabolas. Or download that booklet, the theory booklet, from the link below, which tells you, how the graph looks, where the graph is sketched, and all of the things like axis of symmetry, equations of asymptotes, all of those beautiful things that count a few marks but can trip you up in the exam or score you a few marks, because that would be awesome. So let's dive into a nice, wonderful example about how I expect an exam question to be. So this first question is specifically talking about h of x and k of x, h of x being a hyperbola because the x is in the denominator, and k of x is an awesome exponential graph with the x in the exponent. Now I'm going to start on a new page by looking at question 6.1. Now question 6.1 first of all asks us to draw the graph. Now, before I actually start drawing the graph, I want to read off all the information I can. But for this, I've got to know my theory. So first of all, the A value is 3, which is positive, and therefore the graph lies in the first and third quadrant formed by the asymptotes. Do I really have to know this? Yes, you do. Because it's a nice test whether your x and your y-intercepts are actually right. Now next up, I've got my asymptotes. The two equations of my asymptotes are x equal to -2 and y equal to -1. Now I do have to determine x and y-intercept, so let's dive into the difficult one with the x-intercept, where I let y be equal to 0. So if I let y be equal to 0, I'm sitting with that equation. Now I need to first isolate my function, I mean my fraction. To isolate my fraction, I take the -1 and it becomes +1 on the other side. Actually, I'm adding 1 on both sides, just for the guys that like to be really mathematically correct. Now I'm going to multiply straight through by the LCD, which is x plus 2. Which means I'm going to sit on the left with x plus 2 and on the right I'm left with 3. So my answer for my x-intercept is x equal to 1. Again, understand that I now have a set of coordinates. X is 1 and y is 0. To go over to the y-intercept, I've got to let x be equal to 0. So y is 3 over 0 plus 2 minus 1. So it's at a half. Again, this is a set of coordinates. X is 0 and y is a half. In other words, I can actually now sketch h of x. But I'm not going to do that, as you are seeing my writing on the board already. I'm going to go over to k of x, which is my exponential graph. Now, again, I'm going to interpret, but now I'm going to start with an easy one. I'm going to start with the asymptote because that's going to be important for me. The asymptote is at y equal to 1. Now, if I look at the asymptote, I actually are now going to look at where does the graph lie. Now, the positive in front of the 2 says that my graph will lie above whatever my asymptote is. The half, because it lies between 0 and 1, it means my graph is going to go towards my asymptote. Now, grade 11 learners, put a knot in your ear, as they like to say. the term that we use for when a graph goes towards a specific point is convergence. Convergence. That next year when you do sequences and series is going to be a very, very important terminology. So just remember that for when you again come across that terminology. But let's go on. The x-intercept, if I make y equal to 0, and I'm trying to isolate my half to the power of x. So in other words, I'm sitting with a half to the x equal to negative a half. Now that is impossible because a half to the power of anything remains a positive answer. So in other words, there's actually no solution. It will make sense in a little while to you. Next up, the y-intercept. Let's make x equal to 0. And I have that the y-intercept is at 3. Please remember that you have now sets of coordinates. So let's go over to the actual sketching. So there's my set of axes, my x and my y-intercept, or y-axis. Let's start with h of x. I've got my asymptotes at x equal to negative 2, and my other asymptote at y equal to negative 1. A y-intercept at a half and an x-intercept at 1. So on the right, I've got my 1 part of the graph. But remember, there's also a second part of the graph, which is in quadrant 3. Now, this is awesome because it does correspond to the form, because the form says it has to lie in quadrant 1 and 3. Now, let's go over to k of x. Now, if I draw k of x, there's my asymptote at y equal to positive 1. It's got a y-intercept at 3. Now just quickly look at this. Where does the graph lie? Above y equal to 1. So can it go through the x-axis? No. It's decreasing, but it's still never going to cross y equal to 1. And that's why there are no x-intercepts. Interesting how maths comes together. From having a no solution to having no intercepts in the graph. I love maths, guys. I love it. Now, what I'm going to do now is I'm going to go over to a new slide and I'm going to just redraw the sketches, or I actually have it already redrawn, and I'm just going to answer 6.2 and the rest of the questions. So let's have a look at, first of all, labeling the axes. That's very important. Just because I'm a mathematician, I love to label my axes. But let's look at the redrawn new graph. Now, I'm going to now look at the questions that they actually asked me in the original slide. So in the first slide, they asked me 6.2.1, the domain of h of x. In other words, the x values, domain is x. A nice little thing to remember. If you ever get confused about x-intercepts or x and y with domain and range, think about alphabetical order. Domain is first in the alphabet and therefore goes with x. Range is second in the alphabet and hence goes with y. Nice little thing for you to remember. But let's look at the x values of the hyperbola. Now, first of all, let's look on the bottom leg, the leg in the third quadrant. It goes all the way from negative infinity up to negative 2. Now, it doesn't include negative 2 because negative 2 is an asymptote. It also doesn't include negative infinity because negative infinity is a concept. It actually never touches infinity. Now, that is a completely amazing different video one can do about infinity and what infinity is. But I'm not going to look at that because I'm getting sidetracked. Let's look at the leg in the first quadrant. The leg in the first quadrant starts from negative 2 and goes to positive infinity. Again, it doesn't touch negative 2. Now, this basically means x can be any number but negative 2. So I'm just going to actually rewrite it as x can be any number, so x is an element of real numbers, but x can't be negative 2. Now let's look at 6.2.2. the range of k of x. If I look at the range of k of x, remember range is now about y values. So if I look at the y values of the red graph, it goes from my asymptote and above. In other words, the lowest y value that the graph is going to be is 1. The highest value is infinity. Now it cannot touch the asymptote, and it will never touch infinity. I just want to quickly hit the pause button. Please, you don't hit the pause button, but I want to hit the pause button. Please understand, ladies and gents, that it doesn't mean that graphs will never cross asymptotes. The AP Math students in grade 12, you will get graphs that cross the asymptotes. When you get to varsity first year calculus, you will get graphs that actually cross the asymptote. But at school level, in core maths, it never crosses the asymptote. So I like to think of asymptotes as being electric fences. If you try hard enough, if some functions are smart enough, weird enough, it can actually cross that electric fence. But most graphs are going to get close to that electric fence, but they don't want to get shocked, so they're not going to touch it. Can't touch this. That's what I think about with asymptotes. I'm going to stop my singing and carry on to the next question. So question 6.2.3. Question 6.2.3 asks us the axis of symmetry with a positive gradient. Now for this you need your theory, because the theory of an hyperbola says the following. It's y equal to positive x plus c, and it passes through the coordinates where the asymptotes cross. You have to know that. Now there is a second one, y equal to negative x plus c. But that has a negative gradient, so I'm not going to look at that. So now I'm going to substitute that set of coordinates in. I'm going to solve for c, and I have my axis of symmetry, y equal to x plus 1. Now I'm going to quickly carry on to 6.2.4, which says h of x equal to 2. So what I did was I took my equation of h of x and I simply substituted h of x by 2. Now what this means is actually I made the y value 2. Now I'm trying to solve the specific x value. So now, again, I've got to isolate my fraction. So if I isolate my fraction, I'm going to take the negative 1 and make it a positive 1 on the other side. I'm going to times straight through by x plus 2. I am going to try and solve x now. And therefore, x is equal to negative 1, which means it's actually a set of coordinates on the graph. So if I look now at the last question, which is question 6.2.5. Question 6.2.5 again requires me to redraw the sketch. Now I'm going to redraw the sketch again, simply for this next exercise. So for this next exercise, I've redrawn my sketch. And the question asks us, where is h of x times k of x larger than 0? Please understand, they're asking for the y values. In other words, when is the y values of h times by the y values of k bigger than 0? Now, because they're asking me for y values, I'm going to look at the two graphs that were sketched, and I'm going to ask myself about whether the y values are positive or negative. So I'm going to start with h of x. Now, let me just backtrack a little bit there. Now, h of x I'm going to do in blue. Let's start on the left-hand side of negative 2. On the left-hand side of negative 2, are my y values positive or negative? Well, they are negative. On the right-hand side of negative 2, I have two sections. I've got the section between negative 2 and 1, and then from 1 to infinity. Now let's start between negative 2 and 1. then my y values are all positive, all the way up to 1, where it reaches 0. Then my y values become negative, from 1 all the way to infinity. Now I'm going to repeat this process, but just with k of x. Now with k of x, I'm going to go in green. And the amazing thing is that it's positive everywhere. It actually never goes below the y or the x-axis. So my y values are never, ever negative. Now that's going to help me a lot when I interpret this question. Now what are they actually asking me? They are asking me where is a function or a value times by another value positive. So I've got two options. Either I must have two positives multiplied by each other or two negatives multiplied by each other. Which means, where on the graph do I have a positive y value and a negative y, or positive y value and another positive y value directly above each other? Or a negative times by a negative directly above each other? Let's start by looking at on the left-hand side of -2. There, h of x is negative, but k of x is positive. So that doesn't work. If I look between -2 and 1, I have a positive green and a positive blue. So that works for me, all the way up to 1. But on the right-hand side of 1, I have a positive for k of x, but a negative for h of x. So that doesn't work. So we have actually only one domain that works. And this domain is for x between -2 and 1. But, first of all, at h of x, -2 doesn't exist. So I cannot include it. And at 1, both of them exist, but they do not say equal to 0. So I'm also going to make a round bracket. If that wasn't equal to 0, I would have included the 1 and made a square bracket. But I have to make a round bracket. Ladies and gents, what a beautiful sum. I can almost guarantee you your teacher will look at this and go, I love this question. I'm going to ask this question. For the guys that are, and gals, not just guys, for the boys and girls that are doing GDE, so your public school, they love asking you to sketch hyperbolas. They sometimes ask you about exponential graphs. But in the next video, I'm going to show you some awesome, in other words, weird questions that we can ask before I go over to, exam questions about parabolas. Ladies and gents, this is Sarah van Grenen, Mr. VG, signing out. Remember, you are awesome. Cheers.